Now let's put the various types of meters together into a multimeter. Since voltmeters and ohmmeters can use the same meter movement as an ammeter, a multimeter, or a multi-tester as it is sometimes called, can combine circuitry. Typical multimeters require more switches and meter scale markings for the various functions. A function switch determines whether volts, amps, or ohms will be measured. A range switch selects the ohms multiplier or volts-amps range. An ohms adjust control is present, possibly two, one for 0 and one for infinity. A multimeter is usually either a volt-ohm milliammeter, VOM, or a digital multimeter, DMM. A VOM with internal electronic circuitry is called an electronic multimeter. An electronic VOM is either AC powered or has internal batteries to power both the circuitry and the ohmmeter. A passive multimeter is simply called a VOM and has one or more batteries inside only to power the ohmmeter. Digital multimeters are simpler to read and are generally simpler to operate. Switches are most often easier to set and interpret or aren't even necessary. Some digital multimeters have autopolarity, meaning the leads could be connected to either polarity of a voltage or current source. Some have auto-ranging capabilities, meaning the measurement is automatically displayed in the correct range. Most digital multimeters have no 0 ohms control, since the voltage is automatically constant coming from the electronic power supply. Now let's see some applications of multimeters. Using the ohmmeter function of a multimeter, you can check for continuity, in other words, a complete circuit or wire that might be broken. For instance, this pair of headphones has a problem with the sound being intermittent. It sounds like this. With this simplified multimeter, let's see how continuity tests work. If a wire is complete with no breaks, the meter will indicate 0 or very low ohms. If the wire has a total open, that is, makes no contact whatsoever, the meter will indicate infinite ohms. If the wire has a break in it, that is, if it is making contact intermittently, the pointer on the meter will jump. Using the ohmmeter function of a multimeter, you can easily make continuity tests of fuses. A good fuse, that is, a closed fuse, will measure 0 ohms between its ends. A bad fuse measures infinity between its ends, since it is an open circuit and has no continuity. We can also use the voltmeter function of a multimeter to test whether a circuit or component has continuity, that is, whether or not it has a good contact, whether or not it is open or closed. Here, the open switch will read high voltage because an open switch is a barrier, or represents infinite resistance, dropping all voltage. When the switch is closed, there will be continuity, or 0 ohms, so there will be no voltage. The meter will measure 0 volts. Similar readings would result when checking the voltage across a fuse. If a fuse is good, it's like a closed switch. Since there is an easy pass through it, there will be no resistance, and consequently there will be no voltage dropped across it. A good fuse, like a closed switch, therefore, will measure 0 volts. If a fuse burns open, however, it does not allow current to flow through it. An open fuse, therefore, like an open switch, will measure high or the source voltage. Current can be measured using an ammeter, but that requires opening the circuit to be tested so the meter can be connected in series with the components. This can often be impractical or damaging to the circuitry. Using a voltmeter to measure voltage across a known component while all connections are complete is much simpler. Current can then be calculated using Ohm's law. For instance, in this circuit the voltage measures 4 volts and the resistor has a 1 k ohm rating. The current therefore equals 4 milliamps. This is called an indirect current measurement since voltage is actually measured and the resulting current calculated.